Today we will study a very important concept which is called the function of random variables. So far we have taken a look at different random variables and some basic algebra of random variables. But what is of practical significance is how to deal with function of random variables, because bulk of the course will actually deal with this, right? You are not going to deal with the random variable straight away, but maybe an affine function of the random variable. So the question that we ask is, if I know x, if x is a random variable, if x is a random variable, right? If x is a random variable whose distribution I know, let's say it is Gaussian distribution, right? So what will be the PDF of y, which is again another random variable, that is a function of x, that is y is equal to gx, right? So how to show that? I mean I'm going to show this mapping is, this is the y is equal to gx, this is the function. Now this is the random variable which we already know, and this is the random variable which we are trying to find out. Now one of the important assumptions is that this function should be invertible. That is, we should be able to write x as maybe g inverse of y, right? That we should be able to do. If we are able to do that only under this assumption, then the theory that follows from here is applicable. So let us see the simplest case. For most of the difficult cases, this is not what we are actually going to do. We are actually going to do things in a little approximated manner. That is, we are not going to find out the PDFs. But nevertheless, at least for the very simple one variable or two variable cases, it is instructive to know what happens, right? So let us say I have this. What I will do is, I will start with the inverse transformation. So meaning, if I have this random variable, let's say y, right? I mean, let's say this is hypothetically its PDF, right? This is hypothetically its PDF. So what I will do is, I will take a slice, and I will basically slice between, let's say, y. Now this is y, this point is y, and this is y plus dy, right? I am taking a slice whose width is dy. And now what I will do is, I will try to see, this is the difficulty here, is drawing this up, because every time I try to draw, something gets erased, so you have to bear with me. Okay. So let's say, if I take this slice, it intersects this function at this point, which is, let's say, this is x1 and this is x1 plus dx1. Okay. So similarly, this is x2 and this is x2 plus dx2. Similarly, the last one, right? So now what we will do is, we will try to project these points, that is x1 plus dx1, x1 and x1 plus dx1, to this random variable x. So basically we are trying to do the inverse process. Rather than going from x to y, it is little convenient to start with y and try to look at what happens to x. So what I will do is, I will basically project these points here. Well, the drawing is a bit approximate, but please live with that, bear with me. Okay, so this is your x1, and this is x1 plus dx1. Okay. Similarly, this is given in the slides, so you should not have too difficulty in following. So this is x2 and this is x2 plus dx2. And similarly for x3, we can draw a similar slice for x3. So the idea is, so what we can write now, we can write that fy, so area under, so fy dy, if using the definition of PDF, we can write fy dy is equal to f that is, let's say, probability that y lies between y and y plus dy. So that will be equal to, so we'll have to sum this for all the contributions of x. So that will be PR of a capital X lying between x1 plus dx1 plus PR x2, that is x lying between x2 and x2 plus dx2 and so on and so on. I'm just reducing. So what we are going to write is fy dy is equal to fx x1 dx1 plus fx of x2 dx2 and so on, right, for multiple intersections. So now y is equal to gx. Now I am using small y here because of the convenience of the notations. Okay, so my dy is equal to g dash x dx, or dx is equal to dy by g dash x. So if I make this substitution, now what I will do is, so this is like a side note, and I will substitute it here, substitute this thing to here. Let's say this is 1, this is 1, this whole thing is 1, and let's say this is equation 2. So what I will do is I will substitute this guy, which is, let's say, 3 in 2. So basically I will take this and I will substitute it here. So what will happen? My fy dy, it becomes f x x1, this will become dy by g dash x1 under modulus. Now why I keep it as a modulus, I will tell you little later, because we want to make sure that the probabilities are not negative. Plus fx x2 dy g dashed x2, right, plus so on. So the important thing is we are able to cancel dy from both the sides, that is dy gets cancelled and fy dy, that is fy can be written as summation of f x xi divided by g dashed xi, but whole thing under the mod or the absolute value. Okay, now I can go for 1 to n. Now couple of things to understand from here. The first thing is why why we have drawn a slice from y and it cuts x at multiple points. It simply means that we can have the situation of multiple roots. Like for example, if y is equal to x square, think of if y is equal to x square. So if y is equal to, let's say, again another side note, let's say y is equal to x square, right? So then what does x become? There are two roots basically. X is equal to plus of root y, that is x1, and x2 is equal to minus of root y, right? So it means what? For a single y you can get multiple x's, and that is the reason why we have sort of generalized this expression, that is multiple roots can exist, that is multiple crossings, right? That is the reason why. So the example that is provided in the slide is if x is equal to normal distribution, then what will be the PDF of y such that y is x square, right? So what do you first do is first you get the roots, that is x1 and x2, and then you find the derivatives g dash x. What is your gx? Gx is equal to x square for this case. So g dash x is equal to 2x. So g dash x1 is equal to 2 root y and g dash x2 is minus 2 root y. But you need the mod. Since you need the mod of this, so what do we get? For both the cases it is 2 root y, that's it. Mod of negative is a positive number. So that is the g dash x, and finally what you do is you substitute in this into this formula, and this precise same example is provided in the slide. That should not be a problem.